How's it going, YouTube? My name's Ryan and welcome back to the channel. So today I'm going to be talking about a new idea I've had, and that is social net hyperparameter evolution. Now, I've been working with neural networks for about a week or so, trying to learn how they work and how to build them from scratch, and I've been getting some pretty good progress with it. And to kind of further my projects, I came up with this new idea. So what exactly is social net hyperparameter evolution? Well, it's a bit like robots sharing genes with each other in terms of interactions. They would compare themselves, see if one of them has a better neural network, kind of like a virtual brain than the other, and then will give part of itself to the other to build a hybrid. Kind of like gene sharing. There's certain parts that they would share, but also certain parts they'll keep the same. And ultimately, it would mean that every robot would be not just unique to each other, but probably not even the same next time they meet up. I mean, they could be meeting other robots as well as just learning and adapting all by themselves. Now, this idea might already kind of work, but to a point I see that as a good thing, because it means that I must be somewhere in the right direction, and if I do get stuck, then there might be something out there to help me. I'm still mainly concentrating with one node layer neural networks like perceptrons. I am trying to get into more complex ones, but I want to make sure I fully understand the perceptron, and then the later ones, the higher level, higher layer count multi-neural networks before I go too far. And that's for stuff like this robot here that you might see dangling down. So this is like a little walking robot I've been working on, and that's kind of more in the software stages now. So my aims. Well, the idea, kind of like what I said before, is that the robots can learn by themselves and improve themselves like a neural network already does, but also to actually evolve in a way that it might not necessarily have to rely on its training data and stuff like that. It can also rely on real world data from other robots already out there. I mean, not every sensor is going to be exactly the same, meaning that if it's going to be reading the sensors, yes, they have to be calibrated, but it's not always going to be getting the exact same type of inputs in the same scenario as other robots. Not just that, the simulations only account for so much. There's going to be other things that the robot's going to have to work with. So it's kind of like a way of not just learning by itself, but through also social interactions, kind of talking to the other robots. This will be somewhat limited. For example, the actual architecture of the network will be set. There'll be a constant between all the robots. It's not going to be adding nodes or adding layers or anything like that. There are some bits that will be unique to each robot. For example, every robot would have a learning rate. Every now and again it might slightly tune it by itself, but that's nothing that's going to be shared. That's going to be private and local to that robot. Even the training sets are going to be slightly different. So when the network would be uploaded to the robot, it would already have a alright-ish kind of basic set network already in it. It would be somewhat initialized. It would have weights and biases that will allow it to do the job at some level, just not very good. Meaning that it's not going to be completely learning from scratch. But one of the things I will do is I'll probably use another neural network on my computer to actually generate some of these learning sets. Maybe I might generate 1,000 entries, but each robot gets 100 picked random ones. Or that the inputs to a neural network will be randomized every time. So every robot does get a correct, I'd have to verify it, but does get a correct but unique training data set. As the robots go around and do their job, they will train by themselves periodically, maybe after so many hours. So every time that they know they failed a task, they might log certain things about it, or if there was an outcome that wasn't quite right and it's somehow new, it'll kind of log it, and it will try to retrain itself and see if it can fix that issue. It might slightly tune the learning rate by a random small amount within some sort of range. So when the robots are uploaded, their learning rate will be unique within a certain range, but then it will learn to adapt itself in a smaller range, so it can so every time it trains, it's not going to train in the exact same way. But in terms of the evolution itself, the idea is the robot will know what its sort of average sort of error of the network is, and every time it trains it will be slightly different. The more it interacts with the world and then trains from that, it will be slightly different, and its hyperparameters will change. More specifically, the ones that I will have it that it can share, the values of weights and biases and stuff like that. So when a robot does meet another robot, the idea is that first they'll come up to each other, they will discuss, my error is this, my average error is that, and the one with the better network will share those hyperparameters to the one with the lesser efficient neural network or accurate neural network, implementing itself with its own unique learning rate and its own unique training set, and then it will go off and then carry on learning with this sort of new brain or new parts of the brain, while the actual training part of it is still itself. So by the time they next meet up, for all we know, this one might be better than this one. If not, it would also share its parameters. If we have like a swarm of, I don't know, 50 robots, ultimately they'll be learning by themselves, and every time they meet each other, the better one, the one with the better network, would share elements of it with the lesser one, and it, as a cluster, as a community, they should learn a lot faster than just one robot by itself. And it's one of these things where it, in a way, it'll be somewhat evolving, kind of like almost breathing virtually, or at least that's my hopes, that's my aims. I still have to build it. So let me actually show you some things, because the whole idea about this robot is obstacle avoidance. I kind of set it off. It uses its sensors to try to avoid objects. So let's say we build some sort of layer, some sort of test area. I'm going to build one on Unity. I've been learning that. That's been quite cool. I want to try to learn more in terms of object-oriented programming, and we did some at uni. I wanted to go further with it. So I thought it would be really good to try and do a virtual test area, a bit like what these robots would have had in the early 2000s that came with them. But build one myself that's compatible with modern computers, as well as a real world one, and have it see where the robot goes to avoid obstacles, how it avoids the obstacles before it gets to the destination. Another thing I want to introduce that I haven't done quite yet is tokens. The idea being that a robot would move for so long, and one of its aims, as well as to avoid obstacles, would be to try to get tokens. Ultimately, I will then have possibly another neural network for the tokens, but at the moment I'm mainly concentrating on obstacle avoidance. So every time it sees a token, it'll probably unlock more runtime. Yep, you did a good job, now you can carry on. If it don't and it's doing really poor, it's one of these things that if I can see what robots would be sitting still, because that would be an immediate flag to say these ones probably aren't working to the way that I want them to. They're still avoiding obstacles, but they're not necessarily searching for things for that well, or maybe they're just not even noticing they're picking up the tokens. So here is a little scenario of social evolution. So my error is this: the closer to 0 the better. Oh, this one, the red one, it has a much less accurate network. Its error is greater in comparison. So the blue one would say, I'm going to transfer you some stuff. I'd have to come up with my own protocol for this. The robots actually, here's another one. I have a whole bunch of these. You can see some behind me as well. They actually have these little domes. So they transmit and receive infrared from the remote. So I've been trying to get them to work with the Arduino. So I'll probably have to make my own infrared protocol for this. But so here's my weights, here's my biases, maybe a few other things. And the red one will make a hybrid of its virtual brain, keeping its learning part the same, keeping its training and test data sets, but receiving the actual hyperparameters of the network itself. So rather than just, oh, I'm going to copy you exactly and carry on, I wanted to add a bit of diversity and see, well, I wonder how good it can get with a set training parameter. because ultimately, if I was to give it a certain training parameter, it might not be the most optimal. And there's all these, I found all these cool videos talking about how you can have it so it fixes these parameters themselves in terms of the learning rate. But I thought it would be good to kind of fix them, have it slightly change it, and just kind of see what robot is the better robot out of the lot. Of course, if one robot is going around and changing all the other ones, then that would be kind of seen kind of like the alpha robot as such. You know, that is the better robot out of the lot. But it might not necessarily be a fair test. So at the same time, I have to remove it and hope that another kind of alpha robot don't just pop out of everywhere where it's going to be doing good. It's always naturally going to be doing better than the others, and it's never going to learn from the other robots itself, and the other robots are just going to be just merging with it all the time. I wanted it to be kind of like a more spread, even diversity, so you should have I should be able to have robots away for days, weeks, months, and then come back and be almost completely different in some ways, apart from architecture. And I kind of got some of this idea just from in general. I thought it would be a cool way for robots to be able to share each other. But one thing that I saw years ago actually was a video where there was some kind of robots that are kind of working as clusters. And it'd be like a little robot with a bunch of sensors, and these little cluster robots will kind of work like one big robot, and they'll kind of be able to cross communicate to each other, and there'll be some sort of big area where robot A be put around here somewhere, and it covers this kind of area. You'd have B kind of cover this sort of area, and it'll kind of cover the area kind of like cells, a bit like a phone network. Each robot will kind of have its own cell. Maybe there might be like another copy of the B robot up here, whatever, and each one of them will kind of map out this area. Maybe there's some obstacles here, some obstacles here, and every now and again, if they start to stray a little bit out of their area and then meet each other, A would talk to B and be like, do you know that there's all these obstacles in this area? It would share its map. And it seemed to work quite well. So what they then did is they then had another bigger area that's not quite a straight square, and they'll kind of set all these little robots, every one of them basically the same. Now they kind of knew what kind of mapping algorithm was the best in different scenarios, and what they kind of did, they kind of just released them. And maybe there's some obstacles here and some things here and a whole bunch. And the objective was to map the whole entire area as much as they could. And let's say this robot goes here and goes here. It's like, oh, I know everything here. I was like, oh, I don't know everything some here, but I've also went around here. And where they went was just up to chance, where they decided to move. Maybe they might see an obstacle, move and carry on in that direction till they saw something else. And as a cluster, they were able to map the whole entire area far, far faster than just the one robot by itself. And I thought, well, if they can do that to map an area, then maybe we can do the same for learning. Another thing I saw was this cool sort of game all about training neural networks. So you used to have a starting point here. You would have some sort of stick character, or you can actually design it yourself. I can't remember the name of the game. This would have a neural network on it, and every now and again you'd have a thing like 1 meter, 2 meters, and the objective was for this neural network avatar to get to the end, where every single time it fell over, it would then start again. It would alter its network, it would learn and try to go further. The further it went, the better. And one way this kind of worked behind the scenes, but there was actually loads of these things. There was another one, and there was another one. Every single one of them, the hyperparameters would be slightly changed by a small range randomly. Maybe you might have a batch size of robots of 150 of these little robot stick figures. Some might fall over here, some might fall over here. And after the round, after all of them had falling over or by a time limit, it will say, oh, well, this robot was the better. This is its weights. This is its biases. Well, for all the different layers, I guess, and it will then implement that into the new batch. So our stick figure now has these parameters. This is the round 1, the best of round 1. Let's release another 150 of them. Oh, some of them still end up over here, but this one ends up over here. Okay, let's record them. Let's start again, round 2, with the best one from that, and over a long period of time, all you would have is a stick figure that would reach the goal quite well, having learnt how to get there because of many instances of itself. By every generation, every instance in the batch being slightly different, it was kind of like learning, training its data set, except for rather than getting the same one and doing it again 150 times, instead it would just do it 150 of them and pick the best one. And ultimately, I saw a bunch of people who built these games. They found that doing this method was better than just having one by itself and having to learn to go itself. So my idea is the same sort of thing. It will train within its brain with its training set, but when it does meet another robot, it'll be a little bit like this. So for example, so it will say, well, did I do better in this round or did you do better in this round? I did better this round. Here's my values. Just like this. And every time they meet, it will be a new layer, a new generation. And every now and again, when they're by themselves, they'll then kind of do the other example where rather than trying to find the best out of them, it will just sit there by itself, retrain itself. So I'm going to do another video kind of explaining it a bit better, but that's kind of my idea. I want to try and merge a few different ideas and see how it works. I think something like this might be pretty good to try to see if I can do in software as well, and it might be a good way for stuff like these walking robots to learn to walk, because of course with if it being in software, if it falls over, you know, the Unity engine would see a collision sort of thing, or how, you know, there's multiple ways you could probably do it, and you can just have it just reset. When it's real world like this, it's a bit harder because you have to keep picking it up. Well, I've got it suspended on wires. But I want to try to do a merge of the two ideas, and hopefully it will mean that every time these robots meet, in a way they'll basically be evolving into a better way, or at least a different way of each other, but when it does merge, it will be a better way of itself. Anyway, I think I've talked enough about this on this episode, so thank you for watching. I have a new series coming out. I'm actually going to be recording some of it today with the single neuron networks. So if you want to see a little bit of what I've done so far and how far I've got with my goal, check out those videos. I'll be trying to post as many as I can, as often as I can.
And if I start a commotion, I run the risk of losing you, and that's worse. And I fall in love with someone